In the previous PowerPoints discussing argument and falsification, uh, we come to the conclusion that science work by trying to falsify the pre-existing theory or understanding. Okay, so now this means the theory in science needs to be falsifiable in order to contribute to the science. Okay, so what do we mean by uh, idea or scientific idea or theory needs to be falsifiable? Falsifiable is different from false. So the theory is obviously important to be true, but what's important is it needs to be falsifiable. That means potentially shown to be false. So this means if this particular condition materializes, this theory is right or true. It's actually confirmed. But under some other circumstance, if B happens, then the theory to be false. So you have to be able to, the theory needs to actually set in such a way, you have almost like a clear algorithm of if X theory is true, if Y, the theory is false. So this is an example of non-falsifiable theory. So it's non-falsifiable because it's true in all the circumstances. This is kind of manipulating sort of logic. In the left hemisphere of the brain near the language areas resides two tiny green men. They control electrochemical process occurring in many areas of the brain. However, the green man can detect any intrusion such that one cannot detect their presence. So any finding that you have about the brain will be, according to this perspective, attributed to two green men. Okay? And somebody can say, that's because two green men. But then show me the two green men. No, you can't because the green man disappears and or it's invisible. So therefore, under all circumstances, this is true. Therefore, it's not falsifiable. Therefore, this is not a useful theory.
So I hope that you learn by looking at the slide number 3 what perfect theory looks like by looking at the green man theory. That theory is perfect because the green man does all the different kinds of function, and but nonetheless the green man cannot be detected. Therefore, it's impossible to prove the theory as false. So in this sense, that theory is not useful for scientific purpose. Okay, so that one's an easy one. But here, there are actually in the field of psychology, the distinction between the perfect theory and non-perfect falsifiable theory is more subtle. These are the two examples of very close to perfect theory here. Conflict with unhealthy resolutions between the id and ego often result in psychological problems experienced in persons adulthood. Here, this is a simplified version of id and the Freudian theory. So here, id and ego is like green man. It cannot be detected. That makes the theory perfect. Again, for the repressed memory, that's the second example. Again, the repressed memory, by definition, cannot be actually detected because it's repressed. So that makes this theory perfect or nearly perfect, if not perfectly perfect, completely perfect. So these are the example of perfect theory. So the key idea that you need to be, I want you to be getting up right now is uh, that in order for the theory to be useful, you have to think ahead that this can be proven as a false potentially. It needs to be, it can be challenged, and this is related to the issue about operationalization, uh, which we will talk. So this is going to prepare for why the particular feature of theory is important, and so that's the kind of the question we're going to eventually move on to.
So the important point is that a theory that you are interested in needs to be falsifiable. This means it needs to be stated such that it can potentially proven to be false or incorrect. So a perfect theory does not work. The reason why is because the science in scientific research, one try to falsify the theory, and if a theory is not falsifiable, that logic doesn't work. That's why it's not appropriate. So now let's assume that you have a good understanding about a useful theory, and let's further assume that you have a theory that's falsifiable. Whether or not, whether your product is the theory is on description, causal explanation, prediction, or a comprehensive model, let's assume that is falsifiable. Then what's important is to find an evidence that is actually in support of that theory.
So okay, so the large picture that you should be building right now, by now, not just based on this particular part of the discussion, is uh, the ultimate goal of scientific research is to make a claim. The claim can take the form of about simply describing something is true or something is happening, or you're going to predict the outcome based on a particular kind of treatment, or you want to provide some sort of causal explanation, or you want to build more comprehensive causal models. Those are the four types of the goals that we discussed. So for each of these different kinds of goals, the scientific research should be able to provide some evidence in support of these kinds of claims. So it's complicated. The reason why is the type of evidence that you need is different depending on the type of claim that you want to make. So the description or causal explanation requires different kinds of evidences. And those are the kind of complexity cannot be summarized in just one paragraph. And I'm hoping that you're going to get the sense of the relation throughout this semester. Okay, but still, the point there is a general point that I would like to make. And it's very difficult to summarize what is the strong evidence for all these different kinds of cases. But we can at least talk about what is the weak evidence, what is the sign of weak evidence. Therefore, these kind of evidence should be avoided. Okay, so that's going to be the discussion in the next few slides.
So one example of weak or inappropriate evidence which cannot support a theory is testimonial. Testimonial is a personal account of how a particular method or technique such as particular kinds of dieting programs works and effective. So the common example is TV ad showing a famous actress claims that she has lost a lot of weight using a particular diet program. So this slide explains why a testimonial cannot be a strong evidence. So a testimonial is usually based on a single occurrence, and in particular based on some questionable kind of way of collecting the data, right? So on the other hand, the strength of evidence depends on its ability to rule out alternative explanation. So this is stated in red font. What this means is this happens when a theory, the evidence is actually understood such that without the theory, this particular theory-based explanation, this evidence or facts cannot be observed. So for example, let's talk about this in terms of using testimonial. Testimonial is somebody showing that I'm taking this medicine and I lost 40 pounds, 50 pounds, right? But it could be that 40 pounds, 50 pounds loss of weight in a short period of time could have occurred without this medicine. Okay? Because the reason is this may be due to this particular individual. This may be due to some other things that this person did. Okay? So on the other hand, in the strong evidence, or evidence is strongest when no other theory or no other explanation can account for the presence of this particular phenomenon. So for example, let's take about climate change and say the Earth is becoming warmer. And then one of the strong evidence is simultaneously across many different places on the Earth, all the glaciers are receding and getting smaller and smaller and smaller. So that's an evidence and a fact because it's observable. And then these simultaneous withdrawal, receding or shrinkage of glaciers across all the different places from Arctic to Antarctic cannot be explained without some understanding that overall Earth's temperature is going up. On the other hand, let's say this summer is hot. Well, is there a strong evidence for climate change? It's not, because there is a random fluctuation of the temperature in the summer. Some summers are hotter than the other summers, so it could be just a pure accident. Okay, so as you can see, strength of evidence depends on its ability to rule out alternative explanation. So this means if theory or the explanation is the only explanation, possible explanation that account for the existence of particular facts or observable facts as an evidence, the evidence is the strongest. So this slide kind of details, however, that despite the content of the previous slide, that testimonials should not be taken as a strong evidence. Many people without trained eyes tend to believe that testimonial is strong. And this slide kind of details why that's the case. Some of the reasons include vividness of testimonial, because the testimonial tend to accompany a lot of perceptual and concrete details that makes people to kind of think that it's actually true. And also testimonials tend to work with availability heuristic. That means because of these details, it's easy to remember them. And also, the people have a preference toward a narrative. Good story tend to be believed, even when it's not true. So, testimonial tend to kind of present itself as a good story. Okay. So, however, a typical scientific argument is an abstract statement supported by very complex data that requires a lot of knowledge. So that's why testimonial or single example tend to be trusted more than more complicated scientific evidence that may be often nuanced. And so that's the part that I want everybody to be careful about. So, is testimonial useless? No, testimonial can be used as a good exploratory initial question. Then in that case, your job is to try to falsify testimonial. The bad use of testimonial, on the other hand, is to actually use it as an evidence.
So this last slide actually summarizes the entire discussion on the relation between theory and evidence. So the scientific research involves the goal, which means the goal is the building testable, which means falsifiable theories. Theories can be about description. Theories can be about prediction. Theories can be about causal explanation, or theories can be about comprehensive causal models. So, in scientific research, when you look at moment-by-moment activities, you can't build this theory in just one step. So it involves continuous testing of these theories based on empirical observation. Why we do it? Because we can kind of find the evidence in support of this theory or in contradiction of this theory. That's how science advances. It's the theories gets continuously refined or modified because of the fact, which is the evidence. Okay, but we learn that not all the types of empirical observations are not equally valid. Like in particular, we talked about testimonials; they are weak as an evidence, and but that's just one example. But in reality, it's very complicated, and it's the strength of evidence is in continuum, and it requires a lot of discussion. And therefore, throughout this semester, we will talk about how we can obtain the strongest evidence possible by looking at all the different kinds of attributes and details of conducting research.